Welcome back, students. Now we will verify the relationship between zeros and coefficients of polynomials. There are three examples here given here, and we will verify the relationship between zeros and coefficients of a polynomial. Let us recall that if p of x is equal to ax square plus bx plus c with a not equal to 0, b a quadratic polynomial with zeros alpha and beta, and by the way, we usually denote zeros with the Greek letters alpha and beta. We denote the zeros by Greek letters alpha and beta. They are similar to alpha coincides with A in English alphabet, beta coincides with B, and Greek letters usually, Greek or Latin, usually they start with the alpha and they end with omega, and omega coincides with O in English. So they are mere letters in the Greek alphabet. They are letters of the Greek alphabet. Okay. So no need to worry about alpha and beta. They are mere symbols like A and B. Okay, right. Okay. Then we have shown in the previous video that alpha plus beta, sum of the zeros is minus b by a. This is minus coefficient of x by coefficient of x square. And the product of the zeros is c by a, which is constant term by coefficient of x square. Okay, coefficient of x square, and this we are going to verify. Now let us take the first example. Let p of x to be the polynomial 3x square plus 5x minus 2, 3x square. Now let us find the zeros of this polynomial using factorization by splitting the middle term. Now what do we do is, you multiply these two terms, then you multiply these two. So what you will get is product as minus 6. When you multiply this, product is minus 6, and the sum is plus 5. So sum is plus 5. So what do we get is 6 minus 1. So possible products of 6 are 1 times 6 and 3 times 2. And by investigating this is plus, whereas the product is minus. Since the product is minus, one of the factors must be negative and the other must be positive. But by looking at the middle term, it is being positive. Of the two factors, biggest term is positive. Biggest term must be positive. So that is why we have taken this. So what do we do is 6x square, we are going to split this into 2, which is 6x minus 1x. So we have splitted this into 2. So splitting middle term, we have splitted that into 2 and we got this. Okay. Now what do we do here is, from the first two terms we can take 3x common, and this will be x plus 2, and you copy down this and paste it here, x plus 2. Now what should be multiplied to 2 to get minus 2? So you have to multiply it by minus 1. So what is common in both the terms? This is x plus 2, which is common. What is left out here? This is 3x minus 1. Now we know that this is a linear polynomial and this is also a linear polynomial. So what are the zeros? So zeros of p of x are constant minus constant term. What is the constant term here for this linear polynomial? 2. By coefficient of x is 1. So this is minus 2, that is 1 0, and the other 0 is minus constant term by coefficient of x is 3. So this is 1 by 3. So these are the two zeros of this polynomial. Let us call this as what? Alpha, and this as what? Beta. This as beta. Okay, alpha is -2, beta is 1/3. Okay, we have found out the two zeros. Now let us erase this. What do we do is, so alpha, the zeros of this polynomial are alpha is 2, alpha is -2, and beta is 1/3. Beta is 1/3. Now what is the sum of the zeros? Alpha plus beta, sum of the zeros is -2 plus 1/3. This is -5/3. -5/3. What is the product alpha beta? When you multiply this, -2/3. -2/3. This coincides with, what is the formula for sum of the zeros here? What is the formula for sum of the zeros here? Minus b by a. So minus b by a or minus coefficient of x by coefficient of x square. So what is, so when you compare this is ax square, this is bx, this is c. When you compare this, b is 5, so minus 5 by coefficient of x square, namely a is 3. See, they happen to be one and the same. These two happen to be one and the same. So this is verified. So this is minus b by a, and that is equal to -5/3, and that is equal to -5/3. Likewise, what is the product of the zeros? What is the product of the zeros? Alpha beta is equal to c by a, and this is nothing but c by a, and alpha beta is equal to c by a. They happen to be c by a. What is c by a? C by a is nothing but c is -2, a is 3. So -2 and 3. So they are equal. So sum and product of the roots is verified with the coefficients, corresponding coefficients. Okay, for example 1. In a similar manner, we are going to do example 2. Okay, so you call the polynomial, this polynomial as, say, g of x. So you can call example 2 as, let g of x to be x square plus 7x plus 10. So you can call this, and you can factorize this. So what is the coefficient of x square? 1. So if you want, you can call this as ax square plus bx plus c. And what is a? A can be compared with 1, because a is 1, b is 7, and c is 10. Okay, so now let us find out the zeros of this polynomial. So x square plus 7x plus 10. This is the coefficient of x square is 1. When you multiply these two, what you will get? Product is 10. So product is 10. Sum is 7. So what are the possible factors of 10 are 5 and 2. They are the only possible. When you add these two, you will get 7. When you multiply this is 10. So straight away we can write. So having known the two factors exactly, let us factorize this as x plus 5 into x plus 2. Straight away you can write. Or if you want, you can do. This is 1x square. Write x square. Let us split this 7x into 5x plus 2x and plus 10. This is nothing but, we have splitted the middle term into two terms. So what do we do is, from these two, x is common. So you can take x plus 5. And from these two, and you copy this and paste here, x plus 5. So what should be multiplied to 5 to get 10? 2 plus 2. So x plus 5 is common. So what do we do is x plus 5 times x plus 2. X plus 5 times x plus 2. So what are the zeros here? So zeros of, therefore, zeros of g of x are, this is g of x. g of x are minus 5, right? Or when you give x is equal to minus 5, 5 minus 5 becomes 0. So x is minus 5. And when you give x is equal to minus 2, this will become 0. So minus 2. And let us minus 5, this is let us call this as alpha and this is beta. Now what is the sum of the roots? What is alpha plus beta? Minus 7. What is product there? Plus 10. Okay? But what is the formula for sum of the roots? Minus b by a. Right? What is minus b by a? Minus b by a. Minus b by a is minus 7 by a is what? A is what? Which is nothing but alpha plus beta. Just now we have found out. And what is c by a? C by a is 10 by 1. 10 by 1, which is nothing but alpha beta, and we have just now found it. So we have verified that the relationship between zeros and coefficients. We have verified for the problem 2, example 2. Okay. Likewise, we are going to verify for the problem 3 also. Okay. Now let us call this polynomial as. Let us call this polynomial as what? H of x or some q of x. Let us call this polynomial as what? Some q of x. So this is x square minus 3. Now what is a? A is 1 because coefficient of x square is 1 and there is no x term here. So b is 0 and c is minus 3. C is minus 3. Now let us find out the zeros. So q of x is equal to x square minus 3. X square minus 3. Let us find out the zeros of this polynomial. How do we find the zeros of this polynomial? And you know that 3 can be written as root 3 times root 3. We can write root 3 as root 3 times root 3. Okay? We can write 3 as root 3 times root 3. So what am I going to do is, this is x square minus root 3 whole square. X square minus root 3 whole square. Okay? We can write this. And we know that a square minus b square is equal to a minus b times a plus b. So we know this identity. Right? It's a famous identity, algebraic. Difference of two squares is nothing but sum and difference of the terms. Okay? So this we can write it as x minus root 3 times x plus root 3. X plus root 3 using this identity. So a square minus b square. So a is x, b is root 3. So a x minus root 3 times x plus root 3. Okay? Okay. Now what are the zeros here? Zeros of q of x. Q of x are alpha. 1 0 is when you substitute root 3 here, root 3 minus root 3 will become 0. Or you can use the zero of how to find the zero of a linear polynomial also. So this is one root is alpha. The another root is minus root. Alpha is root 3 and beta is minus. When you substitute minus root 3 here, root 3 minus root 3 will become 0. Now what is the sum of the zeros? Alpha plus beta. Root 3 minus root 3. Sum is 0. Okay. What is the product? When you multiply this, product is minus 3. Product is minus 3. And this is nothing but, what is b? See, alpha plus beta is minus b by a. What is b here? 0 by 1. So minus b by a is 0 by 1. So that coincides with 0. So they are one and the same. Therefore, alpha plus beta is equal to minus b by a is verified. And what is product of the roots? Product of the roots is c by a. C by a. What is c? C is minus 3 by 1. C is minus 3 by 1. And that is also verified. So alpha beta is equal to C by A. So we have verified the relationship between zeros and coefficients of polynomials for all the three quadratic polynomials. Okay.